All right, for today's lesson, we're going to be looking at the mean value theorem. And there's a special case of it. We call it the Rolle's theorem. We'll take a look at that later. So we're going to want to find where is the secant slope equal to the tangent slope. We're going to try to figure out when can we use the mean value theorem. The last one says, how are these two theorems different? The mean value theorem and Rolle's theorem. We're going to see that it's the same theorem. It's just that the Rolle's theorem is a special case. So we'll look into that in a moment. Okay, now we're going to look at all these objects, and we're going to try to figure out if they are associated with a secant line. That would be a line that goes through 2 points. Or are they associated with a tangent line, some kind of instantaneous rate of change or some kind of tangent slope. Okay, first we're going to look at B. You'll see that B goes through 2 points, so that's going to be a secant line. And so B is going to go under secant line. D, it only touches at 1 point, so this looks like a tangent line. So we'll put this one in F. Okay, next one is K, an average rate of change. An average rate of change is a type of secant line. It would be like the total distance divided by the total time, something like that. So we'll put that in secant line. Okay, for J, it's an instantaneous rate of change. So that's kind of like the slope at 1 point. So that's going to be a tangent line kind of thing. Okay, this one says in boot camp, Mr. Leanza ran 3 miles in 17 minutes. So all we know is the total distance and the total time. So that's going to be an average rate of change. That will go in secant line. Okay, for L, it says at 1 point during the 3-mile run, he was going 15 miles per hour. So that's an instantaneous rate of change. So we're going to put that with tangent line. Okay, for G, this is the definition of a derivative. Also, when you see that limit, you know it's calculus, so it's probably going to be tangent line. So let's put this in tangent line. A is just the slope of a line that goes through 2 points, so we're going to put that with secant line. Okay, H is just difference quotient, and a difference quotient is just like an average rate of change, so it goes with a secant line. Okay, last one is our C. You can see it's got the limit, but this is the definition of a derivative at x equals c. So that's going to go with tangent line. And now we're done. Okay, here we're going to try to describe the type of line that we're looking at. Okay, for this first one, you can see that it touches only at 1 point. This one looks like a tangent line, so we're going to say tangent line. For the second one, it looks like it goes through 2 points, so we're going to call this a secant line. Okay, on this last one, it looks like the tangent line would be somewhere around here, and this looks perpendicular to the tangent line. So I'm going to say that this is a normal line. And that's it. At this time, we're going to go ahead and watch the first 5 minutes of Ducati versus Ferrari. You're going to have to switch the video. Okay, here's the link for the video up top.